The next section that we'll be going over is something called inverse functions. But before we talk about what an inverse function is or an inverse relation, first we have to talk about what a relation is. So a relation is just a set of points. So if you have several points grouped together, they are a relation. The way that we find the inverse relation is by something called interchanging the x and y values. So that's the fancy word we're going to keep using. And all that means, okay, inverses, if you think about what an inverse means, it kind of means doing the opposite or reversing something. Well, we're going to focus on the reversing part. So we are going to be reversing the x and y values. Now, be careful. I'm not saying we're going to change the signs of the x and y values. So we're not going to change positives to negatives or negatives to positive. But all we're going to do, if you look at this last bullet point, it kind of explains it. Okay, the x and the y values are just going to swap places in the ordered pair. So the x is going to hop to where the y was in the ordered pair, and the y is going to hop to where the x is in the ordered pair. It's going to be a blast. So example 1, we have a relation here because we have a set, these curly braces, these little kind of sideways bird wing looking things. Okay, they're grouping together a set of points. So we have a relation, which we're going to graph those bad boys. We're going to find the domain and range. And after that, we'll find the inverse points by interchanging the x and y values, our fancy word, it's exciting. We're going to graph those points and find the domain and range. And you will discover something interesting about the domain and range of the original relation and the domain and range of the inverse relation. But I'm not going to tell you about that yet. You're going to have to watch example 1 to figure out what magical things happens with the domain and range. So go ahead and pause the video and get started on example 1. So example 2 and 3. Now we're going to be focusing on inverse equations and how we find them. So in example 2 and 3, you're going to start with an equation in each of these, and then we're going to be finding what the inverse equation looks like. So if you go ahead and pause this video, you can work out example 2 and 3. Now, example 4 and 5, this is where it gets intense. Okay, we're going to combine everything we talked about in the video. Holy hot dog, I'm excited. So, with these two functions, we're going to be doing the same thing. Okay, we're going to start with our original function f of x. And what we're going to do with f of x, we're going to fill out a table using the 5 points. Okay, so this is kind of jumping back to example 1 when we had a set of points. We're going to plot the points like in example 1 and also find the domain and range just like you did in example 1. Now, after that, we're going to be solving for the inverse function or the inverse equation, which that's just like what you did in your previous examples. So, it's combining everything we talked about. And once you find the inverse equation, you'll be interchanging the x and y values like we did in example 1, plotting the points, finding the domain and range, and then the last thing that is something new, we're going to find out that the function or the original relation is going to be symmetrical to the line y equals x when you draw in its inverse relation. So the function and its inverse function, when they are graphed, they should be symmetrical to the line y equals x. So you will see that in the video, and I'm excited for you to see that wonderful symmetry that's going to happen. So go ahead and pause the video and work out the next example problems. As of this point in the video, everything further from this point on involves things that we're going to be covering in honors. So if you're not in honors, you can go ahead and exit out of the video if you'd like, or if you just like to learn what the honor students will be learning, you can keep watching. So, honor students, now what we're going to be talking about is something called functions, which we talked about this in class, but I'm going to refresh real quickly. So, a function, what that is, it's a relation, so a set of ordered pairs, in which each element of the domain, which remember from example 1, the domain are always the x values, is paired exactly with one element of the range, which if you remember in example 1, it is the y values. Okay, and this is just a fancy way of saying your x values cannot repeat. Okay, because every x has to pair to only one y. Okay, the x is only best used with one y value. It cannot be best used with more than one y. So So all that means, if you look down here in our table, if you notice here, this one is a function because none of the x values repeated. We have all different numbers in our x values. Okay, now in this next one, it is not a function because if you see where I have circled here, here and here, we have a repeated number. The 4s have repeated. Holy hot dogs. So this makes it not a function because my 4 is besties with the 7 and 14, which is not allowed. It can only be besties with one number. So shucks, it is not a function. So moving forward, okay, we also talked about a way to know graphically if a graph is a function or not is by using the vertical line test. So all that is if you draw a bunch of vertical lines on your graph, it can only cross the graph one time. It's only allowed to cross once if it's a function. Okay, it fails the vertical line test if it hits it more than once. So this first one is a function because if you see here, every time I drew a line on my graph, it only hit the graph in 1 point. 1 point, 1 point, 1 point, 1 point. Okay, so this one is definitely a function, but this graph right here is not a function because the line crosses it in 2 places, right here and right here. So it super fails. So that one is definitely not a function. Okay, but what we want to talk about, we want all of our graphs to end up having an inverse that is a function. Okay, all of our graphs deserve to have an inverse that will pass the vertical line test. So, moving forward, before we do this, in class we talked about how to determine if things are functions or not. So this is kind of a review of what's in class. So I'm going to go forward from there. Okay, so we want all of our functions to have an inverse that is a function. And we also talked about this in class. So something we can use on the original function. Be careful. This is a test you use on the original. Okay, so if you draw horizontal lines on the original graph, it means that the inverse will be a function because the inverse will pass the vertical line test. Okay, so a quick way to know if you graph an original equation to know if the inverse will be a function or not, you'll draw horizontal lines, and if it only hits it one time, like in this one, if you see it hits it once, and once, that means the inverse of this graph will also be a function, which is exciting. Yay! Now this one, unfortunately, the original graph is a function. If I were to draw vertical lines on the original, it would only hit the graph once. So the original graph is a function, so be careful. But the inverse will not be a function because when you draw a horizontal line across, it super fails. It hits it 3 times. So its inverse graph will not be a function, which makes it sad. But I have a way to help you so that all of our graphs can have an inverse that is a function, which is pretty awesome. Okay, which we kind of talked about this in class as well. We went over this funzie in class, but I'll just kind of go over it briefly again. So in class, you had to determine which of these graphs which of these graphs had inverses that were in fact functions. Okay, so basically if you do the horizontal line test, you know if they will have an inverse that is a function or not. So this first graph, it hits it twice, it super fails it, it fails, no. Okay, so in order to make sure that the inverse will have a function, we're going to have to restrict the domain. So we're going to have to kind of remove part of the graph to make it work. So I just kind of eliminated the negative side of the x-axis, okay, which you could have, if you go back, you could have picked the left-hand side of the graph or the right-hand side. Because either side, if you pick either side, it will pass the horizontal line test. But mathematicians usually like to keep things positive, so usually you'll see people pick the positive side of the x-axis. So we restricted our domain. We went from 0 to infinity on the x-axis, and it can equal 0. That's why I have a bracket there. Or this is where x is greater than or equal to 0. So if we restrict the domain, holy hot dog, it passes now. So now this current graph will have an inverse that will be a function. The inverse function will pass the vertical line test. All right, next graph. Bam, it only hits it once. Bam, it only hits it once. So yay, it passes the horizontal line test, which makes it makes the inverse a function. Sorry, guys. All right, this one, bam, it passes. Bam, it passes. So the inverse will be a function. Bam, this one passes the horizontal line test, and bam, it passes it again. It super passes it. So its inverse will be a function. Same thing here. Bam, bam, it passes the horizontal line test, so its inverse will be a function. Now, this next graph. Holy hot dog, it just hit it twice. So its inverse currently will not be a function, so I must restrict the domain. Again, I'm going to choose the positive side of the x-axis. Yes, it fails right now, but right now it does not fail anymore because when I restrict the domain, which I restricted it just like I did before, I used the positive side of the x-axis. When I restricted it, yay, it passes the horizontal line test. So the inverse will be a function. This next one, oh no, it fails the horizontal line test. Super fails, but I'm going to restrict it just like I did before on the positive side of the x-axis, and bam, it super passes. So this one now will have an inverse that is a function. Now this last graph is kind of a doozy. You gotta watch out for it. So this one like super fails the horizontal line test. It hits it 3 times. Insane. Okay, so it super fails, but be careful. Every single time we've been restricting it on the positive side of the x-axis. We started at 0 and have gone to positive infinity. Let's see what happens when I do that to this graph. Okay, so I restricted it. I started at 0 and went to positive infinity. But oh no, it fails the horizontal line test. So I need to keep restricting my graph until it will never fail the horizontal line test. So I'm just going to give a hypothetical. Say that I restricted the graph to 1 on the x-axis. Now, if you draw horizontal lines, it will pass. Okay, so this one we had to restrict it. We had to start at 1 and it could equal 1. That's why I used the bracket. And it went from 1 to positive infinity, or all the numbers that are equal to 1 and larger than 1. So, no matter the situation, you can assume that you can just restrict it at 0. Be careful, the demon cats will get you. You must restrict the graph until it will pass the horizontal line test. So now, this final example problem combines everything we've talked about. Holy hot dog. So in this one, this is kind of like the last one that you did when you were graphing inverse functions in the original function. So you will fill out the table using those same 5 points we used before. We're going to plot those points and find the domain in range, but if this function fails the horizontal line test, you have to restrict your domain. So that's kind of the extra step in the problem. This is the only extra step you have to do. Once the domain is restricted, you only focus on those values that pertain to your new domain, which I'll go over that in the video if that doesn't make sense. And then the problem flows very similar to your previous example problem. You'll solve for the inverse function, interchange those x and y values, you'll plot the inverse points, find the domain and range, and those two graphs better be symmetrical to the line y equals x. Alright, so this is the end of this Prezi video. Have fun working on example 6.